Hi and welcome. My name is Stephen Tracy, and this is a new video series that I'm starting where I speak with interesting people that work at the intersections of AI, data, and leadership. And my first guest on the show is going to be Dr. Gary Ong. Gary has spent 18 years at the Monetary Authority of Singapore. Most recently, he led AI risk supervision at MAS, where he developed Singapore's first AI risk management guidelines for the financial sector. He was previously division head of investment risk management, overseeing risk management of Singapore's foreign reserves. And Gary also holds a PhD in computer science and AI. And interestingly, Gary and I recently launched a course which is available online that explores the intersections of AI and market research. But we're going to talk more about that later on. Gary, thank you very much for joining us.
Thanks for having me.
So, I've got lots of questions that I want to get into. We're going to talk about your PhD, your background in AI and financial risk, the course that we launched. But the first place that I wanted to start was just your background in general. So, you've worked in quantitative finance, regulatory supervision, you have a PhD in AI, but you're also an exhibiting artist. They seem like very disconnected things: AI, art, financial risk. How is it that you bring these things together?
I actually started in arts policy back in 2003, not finance. So that's the slightly interesting thing. So back in the early 2000s, if anyone from that period remembers, the buzzword was not artificial intelligence or AI, it was creative industries. So I was pretty much doing arts policy. I even helped to create a reality TV show, a regional design competition. So the art connection is not new. It's kind of where I began. Now, for the rest, I would say that it's a little bit of serendipity sparked by circumstance as well. So in 2007, I switched to the Monetary Authority of Singapore. I started with banking regulation. So first day, or rather even before the first day, one of my bosses told me, we don't do every fairy things here like what you used to do back in your arts policy days. Now that I look back, maybe that comment started a rabbit hole for me. I started doing technical stuff on Basel Capital rules, regulations that have actual equations, doing a master's in financial engineering, then quant finance, model risk auditing, then investment risk management. Somewhere along the line, I kind of realized I like technical stuff. I can't really do generalist work. And then at 42, I took a break for a PhD. The interesting thing is actually I applied for finance for my PhD. I got rejected. Somehow or other, I dropped into AI and it turns out to be better than finance. So what connects these disparate things, I think, is innate desire to learn new and interesting things. So over time, somehow or other, they come together. So for example, when I do AI, I'm also quite fascinated by things like fractals, where art can emerge. And in AI, actually, the concept of emergence is also present. So those are the things that kind of drew them together for me.
That's really interesting. I think the other question I have on this is just like, how do you actually balance these different worlds? So you also have a family. You've just recently launched these AI guidelines for risk management, which we'll get to later on. But you're still also making art. Like, how do you find enough hours in the day to balance these different passions?
So maybe I can just take a step back and explain how I discovered art. So actually, art was something I discovered during a very low point in my career. So I was actually doing strategic planning. I hated it because it basically consisted of staffing board meetings, writing speeches, and so on and so forth. So it wasn't really finding time to do art, but rather art actually rescued me during that period of time from that struggle with work. So I started illustrating digital illustrations because those were quite easy. They did not require much materials. You could do them whenever you want. There's Control Z if you needed to undo anything. So in a way, digital illustrations actually is quite a good medium that allows you to do when you have some spare time. But it was an escape valve for me. So what started as an escape kind of became an obsession. In a way, I did many things like commissions, exhibitions, and so on and so forth. So that was quite nice. And how did I balance them? I would say that they are not really separate things to me. It's more of the fact that there's art, there's code, there's writing. I mean, there's a natural time and space in the day for each of these things. So yeah, they are just different facets that I pursue.
That's great. I guess at the end of the day, you just have to make time for the things that you love doing. I wanted to talk a little bit about your PhD. So you mentioned that you did your PhD a few years ago, and it was on the topic of AI. Can you just give us like a brief overview of what your PhD was on, and tell us a little bit about the knowledge gap that you were trying to fill?
So actually, when I started doing PhD, interestingly, this was way before ChatGPT. I actually wanted to do generative AI. So at that point in time, if any one of you all remember, in 2019, NVIDIA was coming up with all these things called GANs, generative adversarial networks. So those are the rage, and they could like generate faces. Those was quite fantastic in those days. So in a way, I wanted to do that during my PhD. But unfortunately, I realized after a while it was kind of hard. The reason being that generative AI research is not easy because it requires you to get a lot of data. The models are rather large and it can take a rather long time to run those experiments. So I kind of ditch it after a while, but just an interesting fact. So what I did was this thing called dynamic multimodal network. So what I did was basically I designed transformer models. So the same transformer models that you see in ChatGPT, etc. I designed smaller versions of it, but it was not for language. It was not for generating outputs or chatting with. It was to model dynamic multimodal networks. So let me unpack that. Dynamic just means that things change over time. So a time series. Multimodal means you mix different things. So, like for example, in ChatGPT these days, you can throw images at it and text in it, and that's multimodality, right? And then networks just means connections between people, right? Or objects, or anything that has a linkage or relationship between it. So my transformers were all to model this, but for specific applications. So for example, for financial forecasting, for user interface modeling, and so on and so forth. So when I did this, just before I did my PhD, I was actually doing model risk management. So I was actually auditing banks' models, and I kind of got into it. I love models. And to me, I think the gap that I was feeling in my knowledge is how much more can I learn about models? And I suppose AI makes the most sense. I mean, if the financial PhD happened, I would have gotten into quantitative models. But since the PhD in computer science and AI happened, I got into more complex models in AI, which I think was the gap I was trying to fill in my mind.
Did you already know exactly what you were going to be writing your thesis on when you started the PhD, or did it kind of unfold after you got
Yeah,
accepted?
no, actually, the only thing that was firm up when I got accepted was my supervisor, who was great. And interestingly, I think if my supervisor had a specific topic or area of focus, I wouldn't have had this journey from doing generative AI all the way to thinking about dynamic multimodal networks. But yeah, it was sort of, as of all PhDs, the first 1 to 2 years are journeys where you explore which is the area you can do well in, and you can publish in. And sometimes your initial passion actually may not make sense. So you just have to change and pivot, just like any startup.
We're going to come back to the AI topics in a minute, but at MAS, you spent 2 years developing Singapore's AI risk management guidelines for financial institutions. Can you briefly summarize what those guidelines are and who they're for?
So the guidelines that we call in short AIRG, a framework, a high-level framework for how financial institutions, banks, insurers, capital market entities should try to govern, oversee, and manage AI risks. It applies to all financial institutions, that's by design, and it also applies to all AI technologies, whether it's machine learning, deep learning, generative AI, or even agentic AI. So we had to be quite flexible in crafting sort of a very comprehensive guidelines which are yet applicable and that can be applied across time. We know how AI evolves quite fast these days. So it is meant to be principles based and not prescriptive because AI moves too fast, but it's meant to cover all the key areas that matter. So oversight, key risk management systems, like how you identify your AI, how do you make sure that you record them in your inventory properly, how do you assess risk materiality, and then all kinds of lifecycle controls, data management, explainability, fairness, monitoring, and so on and so forth. So it's meant to be comprehensive, but high level and flexible enough to apply across all financial institutions and types of AI technologies. Now, the insight that I think maybe someone who has not been working on this area would underestimate is this. when we talk about AI, Gen AI, agentic AI, there's this notion that sometimes things can spiral out of control. We can have this that AI sort of like colluding with each other, or they may spell the doom of us. So we shouldn't think about it that way. I think the way to think about AI risk management is not about some scary AI. It's really just a very, very boring system that you need to manage properly. If it goes haywire, it means that you made the wrong decision when designing the system, which is really about what the AI risk management guidelines are about, really about thinking about it as a system and managing the risk as a system rather than some Terminator like doomsday scenario that AI will bring to us.
So we recently launched an AI course together specifically on how to understand and apply AI to solving common problems in the field of research, quantitative research, qualitative research. One of the things that stuck out to me when we were working that course together was your ability to teach about AI in a foundational way. What I wanted to ask you was, like, the pace of AI innovation development is like really crazy. It seems like every single week there's a new milestone or a new model released, or there's a flurry of new AI tools that you can try out and use. As someone who's immersed in this field and has even done a PhD in AI, what kind of advice would you give to practitioners to help them cut through the noise and not get overwhelmed by the pace of this industry?
So I think something that we sort of emphasize both from the AI and the market research perspective is that we always go by fundamentals. We always go back to what it actually means, not really the shiny new toy. Whether you have a new agentic system like Manus, which was just acquired by Meta, or some other agentic system, end of the day, they are just large language models or Gen AI models sitting in a system. What you are doing is you are giving them access to new things, tools, you are giving them access to memory and so on and so forth. So you just have to break them down into what their fundamentals are and think about managing risk based on the fundamental unit of what the AI is, or understanding how to use it based on the fundamental unit. So sometimes when you look at, for example, ChatGPT, it keeps changing, right? Sometimes it has memory, then another day it has deep research, another day it has some other way of generating applications on the fly, so on and so forth. But underlying it is just the large language model being used in many different ways and orchestrated in many ways. So fundamentals, firstly, is quite important. The second is, whenever you use a tool like ChatGPT, the most important thing is not the tool, it's your problem. What problem are you trying to solve? You have to frame it properly first. Your problem may be a huge one and you can break it down and it gets easier to solve, then that's what you should do. You shouldn't just dump the whole problem into ChatGPT or any other AI tool that you have. And then when you break it down, it makes things easier, right? You can see what happens, you can mitigate the risk of things like hallucination because you can actually monitor some of the steps intermediately. And so comes to my third point, which is basically you should always be as specific as you can. Framing the problem is one, breaking it down, and then be as specific as you can. When you are trying to develop a model, you should be very, very specific about what's the measure of success. So these are the things that I think help us to cut through the noise.
Speaking of fundamentals, when we were working on the course together, you made a clear distinction between generative AI not being representative of all AI. For people who are watching that are learning about the field of AI, can you help us understand that distinction further? What is the difference between AI and generative AI, or even other types of AI? And what kind of advice would you give to practitioners who are just learning about the basics here?
Right now, a lot of people think that AI equals to ChatGPT or Claude or Gemini, and almost all problems can be solved by one of these generative AI tools in some form or other. And sometimes, even when underlying the hood is actually not ChatGPT doing the work, it's some other AI that's doing the work, people tend to think that it's just some monolithic thing that's related to generative AI. So it's not. So generative AI is just one set of techniques. If we think about it, AI is a huge circle, right? And in AI, we have machine learning. And in machine learning, we have deep learning. So deep learning is just a more complex form of machine learning. And in deep learning, we have generative AI. So generative AI is just a way of using certain types of data, certain types of model architecture, certain type of training techniques to actually be able to generate outputs that you see today in your ChatGPT. So it's just one of many things out there. So for market research specifically, if you think about it, we have problems like you need to segment your customers. Is ChatGPT the right or best tool for it? Perhaps, but perhaps not too. Maybe you can find a more traditional clustering algorithm that works better. If you want to do sentiment analysis, Maybe ChatGPT can do it excellent, but ChatGPT is large, it's expensive, and it may be slow. Maybe getting a smaller machine learning tool that can do sentiment analysis to the standard that you already accept is a better choice. So many of these tasks in market research or outside of market research would have had specific machine learning AI techniques that are already there for many years. They may work better, they may not work better, but the main thing that we need to know is there are many of these tools out there. If we just have Gen AI, that means we only have a hammer. And when we meet a problem, sometimes maybe a hammer is not the right choice.
One topic that has that everyone's probably heard about is AI hallucination when it comes to large language models, and it's interesting because it's something that if you started playing with generative AI tools like ChatGPT in the early days, it was a prominent issue back then, and it's still an issue now for people who are starting to use AI more to power their productivity workflows. What advice would you give them for how to overcome AI hallucination, but also how not to get burned from issues like hallucination?
So, in order to think about it, we have to take a step back to understand why it happens, right? So, all models, all AI models are never always right. That's the main thing. Even if you build an excellent machine learning model, usually you will have at most 80 to 90% accuracy. Anything that is 100% accuracy just strikes up red flags. So, that's the first. The second is that applies for generative AI models, right? They are large, they are better, they are more powerful, but it is still a feature that they will make mistakes sometimes. Now, the only problem is for generative AI models, the way they are trained sort of conditions them to always give you an answer no matter what. So sometimes when they do not have the answer or they may not know the answer, they will still give you an answer in a confident manner. So that's what causes hallucinations. It's kind of a feature of both how AI models work as well as how generative AI models sort of train. So we just have to think about it this way. It's just a mathematical model that's making a mistake, but giving you an answer that's in the context of a mistake sounds plausible. So practical advice, now that you understand why it comes about, is basically you should never trust the generative AI model, basically, right? So don't think of it as some human that's talking to you. Think of it as a model that can make mistakes. Even if it's not a model, if it was someone, your child or someone, your employee, and you know that they can make mistakes sometimes, you will check, right? You will always check. They can do the bulk of the work and they can do a great job better than you. But you should still need to check. And sometimes, if you think about it, checking is a lot easier than doing the job. So it is not saying that if we cannot find and there's hallucinations, we should not use it. That's not the point of generative AI. It's a tool for you to get a lot of the job done. But at the end of the day, because of the limitations today, you still need to check and verify it. And sometimes if you are experienced enough, you don't need to read everything to verify whether it's true. You would be able to have some fast heuristics to check, just like you check your employee or your child's work, etc. Right? And the other thing that is quite important, I think, is what I mentioned earlier. You need to be very specific. So generative AI is not a mind reader. It's basically just generating words based on your questions. So if your questions are specific, it will be able to give you better answers because the words in your questions are located nearer to the right answers, basically. So that's the second. And of course, when you actually are thinking about, for example, agentic, right? And you're using generative AI, the problem with hallucinations does not go away. When you build agentic workflows, you can actually do things like reiterations, or you can log what the generative AI generated for that step in the agentic workflow. If you understand that and you build workflows that assume there will be some degree of such errors, you can build more robust workflows that work for you. Prompt engineering itself will never be able to address the problems associated with hallucinations totally. It can help, but it's not going to totally address it.
We recently launched a course on the topic of AI, which covers everything from machine learning, generative AI, and how to apply those concepts to solving common problems you encounter when doing research, such as product research or brand research, quantitative, qualitative, et cetera. It covers quite a lot of ground. But my question for you is, why launch a AI for market research course? You obviously have a very extensive background that covers quantitative, finance, risk management, et cetera. Why focus on market research?
Actually, I wanted to do it because I wanted to learn market research and how to do online courses from you, Stephen. But taking that aside, I always like to go into different verticals, whether it's finance or art, etc. So market research just happens to be one vertical. But if you think about it, market research makes a lot of sense, maybe even more than finance, right? Market research is data heavy, quantitative, qualitative, all kinds of data. And data is what you need to do AI. So basically, AI can be applied in many, many rich areas in market research. So that's great. And the other thing is, people in market research know the field. I mean, they may not know AI, but they know things that are related, research methodology, statistics, so on and so forth. So it's actually if you think about it, it's actually a really nice fit for AI. So why not do a course on market research and AI? Because these two, I would say, they have a lot of synergies in each other.
One of the things we worked on or developed as part of that course was a framework called Frame, which, going back to the point earlier about framing the problem, Frame is there to help you problem solve and apply AI as a solution effectively. Do you want to just briefly talk about what Frame is and how it's going to be useful for students?
So, for both of us, I think we are quite against the notion of just prompt and pray, lah. Basically, just type a question and think that something good will come out of it. So, I think Frame is basically a mental model, a framework for you to use, whether it's machine learning models or even ChatGPT and so on and so forth, or whatever comes out in the future. So, Frame basically comprises five parts. So the first is obviously framing the problem, which I mentioned earlier. So try to understand deeply what are you solving, right? Try to understand what's success in the context of your problem. Because if you cannot understand these two aspects, then I seriously doubt that we will be able to reach success even at the end of the whole AI journey, learning journey. So that's the first. The second part is basically about recognizing what's involved because every problem has different types of data, has different types of tasks, right? So we cover this extensively in the course. We need to understand first what data type are you playing around with? Is it text? Is it numbers? Is it images? And so on and so forth. Because that's very important. Different AI techniques are designed for different types of data. Second, what kind of tasks? When I say tasks, I'm talking about it maybe a little bit in the computer science world, but I mean, these are quite generally understood, right? So, are you classifying something? Are you ranking or recommending something? Are you summarizing something? Are you clustering something? So, these are things that you actually need to be able to know about your problem before you can embark on solving it. Because the next step is about applying the right methods in the right way. And there's no way to know what's the best tool for the particular task. So your problems may have a lot of tasks, and then you break them down, you map them, different data, different tasks, and then you think about what are the best methods to apply to each of them, right? And the fourth part is about measuring, right? If you don't, like I mentioned earlier, if you don't know what success is, then you can't solve the problem. And if you can't measure whether you reach the success, then that's also something that will not allow you to reach your goal. So measuring is very important. And measuring is not about just, oh, taste test, right? It looks right. It must be right. It's not that. You basically have to be very disciplined, right? You need to think about what are the types of scenarios that you can see when you actually run your tool or your model. Get a few representative examples, run them, and then find some way of evaluating them in an objective manner. If it can be measured with things like accuracy and different types of metrics, all the better. So that's really what measure is about, M. And E is evolve. So the main thing that when anyone doing AI needs to know is this: AI is only as good as the data it was trained on. And we know that in the real world, things change, right? Every day things are changing. And because things are changing, the data that the model was trained on, whether it's Gen AI or your own machine learning model, can become stale, can become irrelevant. So you actually need to make sure that you monitor whether the surrounding circumstances or the data has changed and would require you to maybe tweak your model or change the context or the system or the prompts that you use to get your answers. So you need to be able to monitor that. So basically, it is a framework. You can apply it to a huge project that is a real machine learning pipeline, or you can apply it the next time you open up your ChatGPT and think about how you want to ask a question. So that's frame for you.
If someone were to finish this course that we recently launched, what would you say that they'll be able to do after taking the course that they weren't able to do before?
So 5 things. We really hope that they will understand what AI actually is, and it's not Gen AI. So we really give the fundamentals that's important. Second, there is a need to evaluate tools critically. So we do give some information, and a large part of our course also covers that. The third is then they will know how to apply the right type of AI in the appropriate way. Fourth is I think it will hopefully give the learner a way to recognize garbage easily, whether it's someone selling something to them or someone posting on LinkedIn some hype. They will be able to think critically and recognize when it's really good stuff or garbage. And then, of course, the fifth is how do we use AI as a good partner, right? So I think as of this point now, we don't think AI will replace us in many aspects, but how do we use it and maximize how we work with it? That's the fifth thing that we hope someone finishing the course will achieve.
Right. And last question, Gary, who should take this course? And also, who do you think shouldn't take the course?
So, market researchers who want to start using AI in their to solve their problems in their daily tasks, etc. I think this will be quite useful for them. They may be hearing about AI everywhere, feeling some pressure, not knowing where to begin. I think we will provide some sense of that. Practitioners already using AI, but in the sense of just prompting and praying or prompting and not really knowing what's happening behind the scene and not getting the results that they want. I think this course will be suitable for them as well. Leaders who are sort of evaluating and trying to understand how to use AI in the organization. So while we do not cover how to set up a AI project in the organization, I think having a sense of how AI works fundamentally will put them on the right path or help them in achieving this outcome. So of course, anyone who's interested in either AI or market research and is kind of tired of just Gen AI, prompt engineering, this is probably also the course for you. I think people who are just looking for the top 10 prompts, although we do give some prompts, but if you're just looking for the top 10 prompts, this is not really the course for you. We kind of teach frameworks. We do give some prompts and guidance. We even give hands-on examples of how to build a machine learning and use it for market research tasks. So those are things that we do have, but if you just want the top 10 hacks that you can get in 10 minutes, then perhaps this is not the course for you. So for engineers who want to go deep into building, for example, AI engineering or ML ops, then of course we don't cover that. This is more geared towards market researchers who want to learn AI.
For any of the viewers who are interested, there'll be links to the course so you can enroll in the description of the video. Gary, thank you so much for joining today and for sharing about your journey and your expertise in the fields of AI, art, and quantitative finance. It's been great speaking to you, and thanks again for joining.
Thank you. Thanks, everybody.